All right, I'm going to try to create a video that's going to help with the pyramid task that's in CMU. I cannot recall the exact section it is in, but it is where you are creating a pyramid and it has bars and or steps, if you will, and those steps vary in height and vary in width, and it's all dependent upon how they call the function. So go take a look at that if you haven't seen it already. And surprisingly, once you kind of figure out how to draw one of the bars or the steps or the rectangles, a lot of it kind of falls into play. There's very little lines of code that you need to write. But kind of figuring out how to write the bars is sort of complicated. So I came up with this random example. It's again similar to the pyramid task, but not exactly the same because I don't want to just give you the answer. All right, so in mine, I have 10 steps or 10 levels to my pyramid. And no matter what I do, I'm always going to have 10 levels to that pyramid. I am setting this so that there's just one width that's constantly used, and I can talk about how that applies to the pyramid task. But for mine, the height of the bars or the steps, whatever we're going to call them, is going to be 20 every single time. Um, and we'll talk about the width of it as well. Okay, so now these are rectangles. So we are going to have to code a rectangle. And what we need to remember about rectangles is there's four spots. You have the leftmost point, the topmost point, you have the width, and you have the height. Those are the four required parts of a rectangle. And what we're going to have to think about is what's happening here in each of these. All right, so if you look at the left point in all of these, I labeled a few of them. All of these have the leftmost point starting at 0. So that makes that part pretty easy because I know that every single rectangle is going to start at 0. One of the clues for the pyramid task is that we are always going to start measuring from the bottom. And I suppose, no, because the bottom stays the same every single time. The top is what moves up and down. So the bottom is consistent, so you're going to want to start with the bottom. So let's start looking at some patterns and looking at the topmost point from the bottom pyramid. That's kind of confusing. But what I'm talking about is this right here. So my bottom, it's hard to tell the difference there. Let's go with green. My bottom pyramid has the top part of its point, this point right here, is at 350. Now, because the height of my bars is 20, the next pyramid has a height of 330. And then the next pyramid has a height of 310. And every single time that top value, that Y value, is decreasing by my height. So in this case, it's decreasing by 20. I could code each and every individual step if I wanted to, or I can utilize a for loop, a loop that's going to loop us through something over and over again. And the reason we can do that is because there is a pattern. What's happening here is if I started at 350, to get to the next one, I'm subtracting 20. Well, again, I always want to start at the same point. This is essentially an arithmetic sequence, if anybody studied those. If I start at 350 to get to the next one, or the one right above that, I have to subtract 20 two times. Okay? To get to the one at the very, 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 very top, I have to subtract 20 9 times. Okay, I'm not going to write minus 29 times. That's too much. So what happens is in the first one, I'm subtracting 20 0 times because it's just 350. And then I'm subtracting 20 1 time. And then I'm subtracting 20 2 times. And then I would subtract 20 3 times. And then 4 times. And then 5 times. And this is a perfect example of how we can use a for loop. And because I'm going to be changing this number, how many times I'm subtracting 20, I'm going to use a range. So my for loop, I'm going to fit it in here. I'm going to say I in range. And then I need to fill in a value here. Well, because I have 10 bars, I'm going to have my range be 10. What that means is it's going to plug in the values for I starting at 0, then 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's 10 total values of I that I'm going to plug in, but it only goes up to 9, so one less. So what this does is it allows me to not have to write 10 individual pyramids, and we can change things a lot easier then. So when we think that topmost point, the topmost point would start at 350, and then I would be subtracting 20 I times. Now, the order in which you write that doesn't necessarily matter. I could put the I times 20 if I wanted to in the opposite direction. But what this is going to do, if I plug in a 0, it's going to subtract nothing. If I plug in a 1, it's going to subtract 20 and give me this. If I plug in a 2, it's going to subtract 40, which will give me that. So we have this repetition that allows us to write the top that way. Now the width of the pyramid is extremely similar. The width is going to have to do with that x value and how far the step goes to the right. So in this first step, it goes over 350. In the second step, it's going over 330. And the third step is going over 310, right? So we have the same kind of situation happening here as my width is decreasing by 20 every single time. My width starts with that 350, and I am subtracting 20 I number of times. I'm going to run out of space here, so I'm going to have to erase some things. Okay, now let's talk about the height. The height is going to be how tall every single bar is, which if you know, based on what I told you in the beginning, every single bar here is going to be the same. Every single bar is a height of 20. Actually, I will have space. So I can just plop in that 20 there as my height. So I have my left, which is 0. This is my left. This is my top. This is my width. And this is my height. This is very similar to what you will be doing in the pyramid problem. The difference is that the height is not necessarily always 20. What they have, I can't remember exactly the function, draw pyramid or draw something. They will have a pre-made function for you where you're drawing a pyramid, and I believe they have block height as the parameter. This block height, and again, I can't remember if this is exactly right. This block height, you might have an input of 20. You might have an input of 30. You might have an input of 50. It really depends on every single unique situation. So if you think about how that relates here, I used 20, right? But instead of using 20 every single time, I'm going to want to use block height so that that value will change. The only other tricky part about this is eventually in the problem, they end up using a group in order to move the pyramid top, I believe. So you are going to have to make sure that you're adding your rectangles into that group. So think about how you add rectangles or how you add things into groups. And that would be basically the last thing that's involved in this problem. I know that that's probably not the easiest thing to follow, but I hope it gives you some clues as to how to start that pyramid problem.